Hi all, welcome to Easy Tech. Today we'll discuss about data warehousing concept session 4. In the previous sessions we discussed about ODS, characteristics of ODS, data warehouse characteristics, data mart, then the techniques for building the data warehouse, that is bottom up and top down approach. So if you haven't watched the previous sessions, I'll recommend you please go through the sessions for the better understanding of the topics. Let's continue with the today's session. So today's agenda is data modeling. So what is data modeling? Data modeling is nothing but how you gonna construct your database, structure of a database. That is data modeling. Then data modeling techniques, how you gonna build that, which are the different techniques used in the data modeling. One of the technique is ER model. Then data modeling types. The types is conceptual, logical, and physical, and their differences. And why not ER model? I mean, why we are not using ER model in the data warehousing? ER model has been used in the OLTP, but not in the data warehouse. So why? So we'll see in later. Okay. Let's start with data modeling. So very first, when someone says I want to build a data warehouse, it needs a database to store the information, the coming information which we stored. So we need a database. Now in that database, how you structuring your data? It is described by data modeling. It's kind of, it has all the table, columns, and their relationship. It's a blueprint of your database. You can say that. Okay. So as we have all the information, the structure and relationship, it is very powerful in expressing the business requirements. Okay. Data modeling concept. Let's try to understand this data modeling with the help of an example. Consider a scenario where an organization ABC wants to build a house. He wants to build a house, and we'll compare how we build that house. We compare with that your database. That is how we're gonna construct your database. So if I am a ABC company and if I want to build a house, what I do first is I'll ask a architect for a plan. I'll ask him and I'll share my requirements. So ABC company is planning to build a guest house, that is a database. ABC call building architect, that is now that architect, and here in the database architect called as data modeler. I have given my requirements to the building architect. The same way business has given the requirement to the data modeler. They are nothing but business requirements. Then the architect builds a plan and it gives to me back. This is the plan, sir. You want this house with the 4 floor and all the inner insides. This is my plan. The same way here data modelers develop a plan which is called as data model, and it gives to business. Now what we do when we have plan, we call the civil engineers for building a house. So here same, that plan we call DBAs who build a database to construct a database. Got it? It's pretty much same. Just relate with these two things. Same way, if you are building a house, You need all these: architect, model, plan, and the engineers. Same way, when we are constructing a data model for your database, you need a data modeler, the business requirement. He builds a plan out of that, and he then the DBA creates that plan in the database. Okay, data modeling techniques. Majorly, there are two techniques which has been used in the data modeling. One of them is ER model. ER model is very simplest and straightforward technique. It has only entities and relationship. It addresses only data and their relationship. Classic, simplest. It's a base for most of modeling approaches. And as I said earlier, it's only mainly used, it's not only, it's mainly used in OLTP. What is OLTP? OLTP is your ODS. Okay, don't forget, ODS is at the start what we discussed. ODS is, and OLTP, they needed to run your business, day-to-day business. Okay, second one is dimension modeling. We'll discuss this dimension modeling in the upcoming sessions in details, but let's have a quick overview what exactly it is. Dimension modeling is nothing but we represent data in a very standard manner for the high performance. So in the data warehousing, we use this dimension modeling. In this dimension modeling, we have multiple key table that is called as fact, and the dimension tables. What are the facts? What are the dimensions? What is this entity? All these terms we're gonna discuss one by one. Okay. Every dimensional model is composed of one of table with the multi-part key, that is fact table, and set of smaller table called dimension tables. As I told you that this is majorly for the high performance access with the standard way of storing the information. We distribute the information into the schemas so that we have a good performance. Don't worry about this dimension modeling. We're going to discuss in the upcoming sessions, not today's session. Okay, in detail, each and every term which we used here, that is fact, dimension, schema, queries. Okay, let's focus on ER model. As I said, ER model is focused on the data and relationship. That's it. So here we have to identify first the entities, then the attribute of that entities, and the relationship between them. So what is entity? What is attribute? We're gonna discuss later in this today's sessions itself. Okay. So for the ER model, we need to identify the entities, then their attributes and primary keys, and relationship. Let's talk about these terminologies. What is entity? In a layman language, entity is a thing for which we want to store information. Anything, any in the organization, anything for whom you want to store the information, like employee. I want to store information about my employee. Employee is an entity. I want to store information about a transaction. A transaction is an entity. I want to store information about a product. Product is an entity. So when we are saying a particular thing as entity, there are multiple instances should exist. Like employee, we have multiple employees in organization. Product, we have multiple products in the organization. Okay, we should have a clear definition so that it will not confuse the departments or anyone else. It is characterized by noun. Example, as I product, employee, sale, loan. Next is entity attribute. Attribute is nothing but some information about your entity. So for employee, what is the name of employee? What is the age of employee? What is the email ID of employee? So information about an entity. Attribute value. What is the value of your attribute? As we discussed, employee name, employee email ID, these are the attributes. But exact value, like myself, Prashant, employee name is Prashant, employee email ID is psontakke@gmail.com. So these are attribute values. Prashant, exact email ID, they are the attribute values. How we represent ER model? So ER model represent as a rectangle. So here university student is a entity, and all are the student ID, student name, student date of birth, student age are the attributes. Primary key is student ID. So what is primary key? I'll tell you later. Primary key. Okay. Very simple definition. A key in a table or for an entity by which we are uniquely identify that entity. So for me, customer ID 1, by which I'm gonna identify that particular customer. So what is the, if I want to have information about IMA, so someone said tell me customer ID 5. Okay, so that means by the customer ID I can identify the peoples. So primary key is nothing but a unique identifier for your entity. Then we have a foreign key. Foreign key is primary key of a particular table exists as a foreign key in the another table. So here, if I see for sales table, we have sales number as a primary key, but all these customer number, staff number, shop number, they are coming from some other tables, and they are primary key in that particular table. Like customer number, customer is coming from my customers, and that number is a primary key in that table. So here that becomes a foreign key from this table. Same as a staff number. Staff number is coming from vendors here, and that is a primary key in that table. Again, shop number. Shop number is coming from shops, and that is a primary key in that table. Got it? Next is data modeling types. So whenever someone says I want to build a data warehouse, or I want to data model a data warehouse, I mean in the data modeling techniques, how we do, there are steps to a data modeling. Okay, uh, when you start, we have different levels, steps, whatever you call it. So the steps are nothing but, the very first one is conceptual data model. Conceptual data model is business users view. How business users thinks what are all entities should be part of my model, how they related with each other. That's it. It's a very high level from the business user standpoints, what they want and the relationship between the entities. Second is logical data model. Logical data model is all the details with that entities as much as we can. I mean, whatever possible details we can provide or we can business can gives us, we should have that in the logical data model. Again, the primary keys, the foreign keys, the relationship between entities, they should be in detail without how we gonna implement in the database. Only difference is we are not worrying about how we are implementing that in the database, but what we want is we want all the every minute details about my entities, what are all attributes we want there in that entities, the relationship between different entities. Okay. Third is physical data model. So physical data model is we have all how we're going to implement that physically in the database with all the data types and the relationship between the different entities. Here is a high level look. So conceptual data model is users view, independence of physical implementation. That is users view, business users view. Then logical data model, meet the requirement of a database system or a data warehouse. Have all the details as much as we can, meet all the requirements. Third is physical data model, that is implement within a database system. That is actual implementation in the database with all the data types and all tables. Let's see one by one. I'll explain all this in details and with the example. So uh, let's have an example. Business users wants their sales by every store. I mean, um, like Vodafone will continue the same example throughout the our journey. So Vodafone company says I want to have the sales of every store or maybe sales of all over India, and I want that distribution over the store wise distribution, how every store is performing and what are the products we have. So as we discussed, conceptual data model is having only the user's view, entities and relationship between them, right? Conceptual data model identifies the highest level relationship between the different entities. That's it. We don't want the every minute details here. We just want the what are all entities and the relationship between them. This is how we can implement that. I want the sales, what are all the stores affected, which is the product, and when it is sold, device, I mean the date, correct? Let's jump on logical data model. So logical, as we discussed earlier, logical data model is having each and every minute details just without focusing on how we're going to implement that in database, but we need all the details about your entities, every attribute, what we want, what business wants, okay, with relationship between the different entities. So a logical data model describes the data as much detail as possible without regards to how they will be physically implemented in the database. What are the features of logical database data model? It includes all the entities and relationship between amongst them. All attributes for each entity are specified, that is every minute details. The primary key for each entity, foreign keys, and the normalization. So let's take an example of same which we saw in the conceptual model. We have that entities. Now how it will be changed in the logical model. Okay, so this is my cell entity, this is my store entity, this is my product entity, and this is my time entity. So these cells having all these keys, all these attributes what we want, that is store ID, which from which store the product has been sold. This is actual product ID and when it is sold and how much items of that product is sold, like 1 2 3 4 5, and what is the amount. and they are related, like store id is foreign key from my this table store id, product id is a foreign key from my this product table, and the date is foreign key from my this time table, time entity. Okay. Third is physical modeling. Okay, this is what exactly we want in the database. Now when we talk about the physical modeling is what we want in the database. How we gonna implement that in the database? What are all the constraints, primary keys, foreign keys, relationship? All we want that in the database. So now here I want each and every detail. What are the data types? What are the constraints? So constraint is something, probably we'll discuss this later. Otherwise we'll just move the agenda. Okay. So what we all need these things in the physical modeling. So what are the features? Specification, all the tables and columns, like these are my tables, and this table contains this much columns. Foreign keys are used to identify relationship between tables. So till physical modeling we were talking about entities. Now we have shifted that term into the table, right? So that is the first one. When we are talking about physical modeling, we talk about actual implementation, and in the database we don't call this as entity, we call them as a table. So table, we need all specification of tables and columns, primary keys and foreign keys, and relationship between the tables. So as we are discuss, I mean we are differently terminologies, different way of handling. It makes physical modeling is bit different from the other two models. How we convert that logical model into physical model? Okay, the very first we discussed, we convert entities into tables. Then attributes, we have the entities, we have attributes. Here we have tables, we have columns. Relationship is in foreign keys. Modify the physical data model based on physical constraints. So constraints we're going to discuss later. Now same requirement, how we going to implement in the physical modeling? We talk about conceptual model, logical model. Now the same one we talk in the physical diagram. The sale entity becomes fact sales, where I'll store all the information by which store we have sold that item, which is the product been sold, on which date it is sold, how much items, I mean how much quantity we have sold, and the how much amount, with all their data types. So data types is something how we are expecting that data. Integer is like 1 2 3 4 5, 101, 105. So this store ID is stored in the dim store, and that store has all the information like store ID, what is store description, where it located, what is the region name, when it is created. About product, we have all the information here like product ID, product description, what is the category, what is category description, what is price of that product, when it is created. Date, here we have a dim date. We have date ID, date description, month ID, month, I mean for that date, what is the month ID, what is month description, which is the year, which is week. Okay, so this is how we convert every data model, I mean step by step modeling of my requirements. This is high level 3 conceptual data model, logical data model, physical data model. A glance, at a single glance, it's the same one which we discussed. Okay, lot many times we the interviewer or anyone ask what are the different says between the these features, I mean these model techniques, conceptual, logical and physical. This is a high level glance. We have entities in the conceptual and logical data model. We don't have that in the physical model. We have relationship in the conceptual and logical data model. We don't have that into physical model. What we have is we have foreign keys, we have primary keys, then attributes. We have that attributes in the, we don't have attributes in the conceptual data model. We have logical in the logical data model. We have primary keys in logical data model as well as in the physical data model. We have foreign keys in the logical and physical both. Table name, column names, column data types we have only in the physical data model, not in the conceptual and logical data model. This is the theoretical comparison. I'll not go into details for this one. This is kind of very theoretical what we need. Just on my purpose is everyone should understand what is conceptual data model, what is logical data model, what is physical data model. The differences actual when we talk in terms of business, how they are differ from each other. This is very technical, but if someone wants, they can go through it. If we have any issues, they can contact. Last is why not ER model. So we talked about ER model and dimension model, but we don't use that ER model in the data warehouse. We use ER model only in OLTP. What is the reason behind it? Why we are not using? So when we are talking about data warehousing, data warehouse, every business users expect that I want this answer. I have multiple years of data. I mean 5 years of data, and I want analysis out of that. Where ER model is not that much straightforward. It's very simple, but not with the kind of complex data. I mean huge data. It's very with the increase of data, it becomes slow performing. It's hamper with the performance. I mean performance gets impacted. Second, the way users, I mean everyone has their opinion. Users comes with the different questions. In the ER model, that presenting that questions in the SQL or representing that queries, it's very hard. They want very straightforward. This is transactions, this is my 5 days transaction, that's it. That's the ER model. So ER model is generally do not work well for the queries that performs historical analysis. Why? Poor performance because of the data amount. And the second is difficulty in posing the questions, because when we are trying to have a trend, we comes with a different permutation and combination and every aspect which we want. So that posing that every aspect is very hard in ER model. So that is, these are the main two reasons why ER model is not being used in the data warehousing. Second, or when we are talking about the end users cannot be remember all ER model. I mean, when you want to pose a questions in a ER model, you need to be very clear about how they have structured, which is not the case with the dimension modeling. If I just want to have my area, it's very easy. I'm focused on only my area. I don't want how we have structured in the dimension modeling all the concepts, but that is not the case in the ER model. We need to have well understanding of ER model for posing a question. That's the same way end users cannot navigate an ER model. There is no graphical user interface or a GUI that makes a general ER diagram and make it usable by end users. ER modeling is not optimized for complex and ad hoc queries. Then what is ER model used? For what? We have a ER model, right? And it's been used somewhere. That's why we are discussing about it. So ER model is majorly used in the OLTP, where we don't want the analytical questions. We have very normal queries. What is my today's transaction status? What is the status of this transaction? Particular XYZ transaction ID. Simple, straightforward questions which we have for day-to-day life to run the business. So that is been solved in the ER model, that is OLTP. So ER model is used in OLTP, not in the our data warehousing. Got it? If you have any questions about this session, feel free to comment and I'll try to answer them as soon as possible. Thank you guys. Have a great day. Bye bye.